Assalamu alaikum kids, this is Ayaz again, and I'm going to teach you math for grade 7, and this is week 4. So week 4 lecture 5. Topic is the same other forms of inverse proportion, which you can find on page 29 of your book 2. And as usual, this is the last lecture on this topic, and I used to dedicate that last lecture for the summary. So now in this lecture we're going to revise what we have done conceptually. This is the same stories in front of you, that what is inverse proportion, and inverse proportion is between two or more quantities. If one increases, other will decrease, one decrease, other increase, and this increase or decrease has to be in proportion. Mathematically in front of you, y2 or y1 x1 over x2. As I told you, this relationship is not same as direct proportion. y2 over y1, x1 over x2. Or mathematically you can write, just cross multiply, you will get x1 into y1 is equal to x2 y2, means the product. Product means multiplication. x1 and y1 are basically multiplied here. The product of two values of one quantity of one variable is going to be equal to the product of two values of the other quantity. Graphically, the graph between y and x is going to be hyperbola, not a straight line, while the graph between y and 1 over x will be a straight line passing through the region. Here I will show you those graphs also now. Here is the first one. If you plot the value of x, let's say on x-axis, and the value of 1 over x on y-axis, you see the region is there, so you will come up with the straight line passing through the region always. While if you plot the graph between y and x, mean the values of y on one axis and the value of on x on the one axis, you'll come up with the hyperbola. This is the shape of the hyperbola. In fact, kind of half of the hyperbola, you could say. It's not a curve over here. Okay, this concept of inverse proportionality, I will draw a little bit of mathematical relationship in front of you now. Since y is inversely proportional to x, so you could see mathematically we could write it down. Y is inversely proportional to 1 over x. This is sign of proportionality. So removing that sign of proportionality with the equal sign, I have to introduce a constant k, which I did it. So now y is equal to k over x. So mathematically you can write it down this way too, just to bring that x from the right side to the left, so multiply it over there. So k is equal to xy, xy is equal to k. So means in case of inverse proportionality, the product of the two values of the two variables is always going to be the constant, same constant, no matter how many values you take different values, the product is going to be always going to be same constant k, and that's why it's written over here in the words over there. So let's take x1, x2, two values of the one variable, and the corresponding values of the other variable y1 and y2. So a corresponding value of x1 is y1 and the corresponding value of x2 is y2. So for the first pair x1 and y1, the relationship is going to be x1 into y1 is equal to k. This is equation number 1. For the second pair, x2 y2 is equal to k. Same. Remember, constant is going to be the same, k. Whatever the k is, 3, 4, 10, whatever it is, 0.5. So from 1 and 2 equations, We can equate them because the right side is equal, so x1 y1 is equal to x2 y1 y2, or mathematically you can see just play with it and you can write this relationship which I showed you as you in every lecture I show you. Same relationship is there. And from the word problems, today's topic, like the topic, we have other forms of inverse proportionality where there is no linear relationship. The powers are cube roots, square roots, other things are involved over there. We did this question, force law of gravitation. Force F is inversely proportional to square of the distance d. So mathematically we can write it on F is equal to k over d square. So if we draw the graph between F and 1 over d square, means the value of F on one axis and values of 1 over d square on the other axis, is definitely going to be a straight line passing through the region. But if we draw the graph between F and d, the values of F and d, you will see it's not going to be a straight line. And this question again about the volume, this question is there in your book. I have to just take the statement, for little statement there, in which it says for fixed volume, any fixed volume, basically is taking the shape of cone actually. The height of the cone h is always inversely proportional to the square of the base radius r. Remember, height is also measured in meter, centimeter, length, and the radius is also a length, centimeters. So mathematically we will say here h is equal to k over r square. Again, if we plot the graph between h and 1 over r square, is going to be a straight line passing through the region, while the graph between h and r is not going to be a straight line. Okay, champs, I have a small test now to see how much the concept you have absorbed or understood. Ready for the test? And what you could do is take a piece of paper, write it down, these questions, solve them, and send it back to me. Here is a small test. The first question is just stating which two variables are inversely proportional. So remember, you had done the practice now, and there is a question in your exercise also. So try to figure it out. Not very difficult to mathematically play with it. Take the denominators on the other side, and if the product is equal to a constant value, remember the constant means something 4, 2, 5, 7, 8, these are constant things. So then you decide which two variables are inversely proportional. Second question is also simple. So z is inversely proportional to w plus 3. So one complete pair is there, 4 and 3. So you have to find the value of w when z is 2.4. So take your time, solve them, and I will wait for your responses. Basically, see how much you understood the topic. And that's it for today, and that's it for this topic, other forms of inverse proportionality. So take care. Thank you.